Hello everyone, welcome to Wings of Physics. Myself Deepali Kulkarni from PVP Junior College, Pravaranagar, Loni. We will continue our topic structure of atoms and nuclei. In last lecture, we studied about the difference model of an atom, and in that lecture we also studied the Rutherford's model of an atom. Today we will study what are the difficulties are in Rutherford's model of an atom. Okay, without wasting the time, let us start. What are the difficulties? Difficulties in Rutherford's atom model. In Rutherford's atom model. Okay. In Rutherford's atomic model, central part of the atom or central core of an atom, that is nucleus. And in that nucleus, all positive charge is situated and most of the mass, means 99.9% mass is concentrated in that nucleus. And electrons revolve around the nucleus. Electron, that is nothing but an accelerated charge that revolve around the nucleus, and most of the space, that is empty space. Then this charge is accelerated charge and it performs circular motion, and according to the Maxwell theory of electromagnetic radiation, the accelerating charge, it always radiates energy, means it emits energy, that electron emits energy. Due to that, its energy goes on decreasing, and its energy goes on decreasing. Therefore, its path, radial inward path, also goes on decreasing, and it falls into the nucleus, and the atomic structure that gets collapsed, means there is no difference in between nucleus and electron, and that is the first difficulty arises in Rutherford's atomic model. Okay, I repeat, electron, that is an accelerated charge, it performs circular motion, and the accelerated charge always radiates energy. Due to that, the energy of the electron that goes on decreasing, and therefore it follows inward spiral path of decreasing radius, and at one particular time it falls into the nucleus, and nuclear structure, that atomic structure, that gets collapsed, and this is the first difficulty arise in Rutherford's atomic model. Then what is the second difficulty? This is the first difficulty. What is second difficulty? When that electron follows inward spiral path of decreasing radius, at that time its angular velocity and angular frequency both goes on increasing, or its wavelength goes on, both angular velocity and angular frequency, that goes on increasing, and its wavelength, that goes on decreasing, and therefore it gives a continuous spectra. This is the continuous colors are present, and that gives continuous spectra. Continuous spectra. It gives the continuous spectra. But what is the actual fact? In actual fact, it gives the line spectra, means that is not an agreement with the experimental result. In actual experiment, it gives line spectra of particular fixed wavelength, and therefore it gives line spectra, and therefore it gives the constantly increasing frequency or angular velocity, decreasing wavelength, it gives continuous spectrum, but in actual fact the line spectra is there, and therefore Rutherford's atomic model, that does not explain the atomic spectra, and this is the second difficulty. And to overcome these difficulties, Bohrs proposed his atomic model, and now we have to study the Bohrs atomic model. Okay, Now, Bohr's atomic model. Bohr's atomic model. Bohr's atomic model. It consists of 3 postulates. Okay. Then first postulate. The Bohr's atomic model, that is for hydrogen atom. And in hydrogen atom, what is the case? The one proton is there and one electron is there. And that electron revolves around the nucleus in circular orbit. And that is nothing but a circular motion. And therefore, the first postulate. What is the first postulate of Bohr's atomic model? The electron in an hydrogen atom, electrons revolve around the nucleus in a circular orbit. And that is the circular motion. We already studied in first chapter, that is rotational dynamics. The circular motion that is due to the centripetal force. Means the centripetal force, that is the cause of circular motion. And therefore, the centripetal force in this case, then ME, that is the mass of electron. Now, let us consider the term ME, that is mass of electron. Mass of electron. Then Vn, that is velocity of the electron in nth orbit. Velocity of electron. Then Rn, radius of that orbit, for which velocity is Vn, radius of the orbit. Radius of the orbit. Then Z, that is the atomic number, means number of protons. Z, that is the number of protons or number of electrons. Okay. And now consider the case, the centripetal force for this circular motion, that is nothing but, we know the formula for centripetal force, mv square by r. Now, we rearrange this formula. Instead of m, me is there. Instead of v, vn is there. And instead of r, rn is there for this case. Okay. Then, the necessary centripetal force, that is for circular motion, that is balanced by the electrostatic force of attraction between positively charged nucleus and negatively charged electron. We know that if two charges are there, then plus E, that is the charge on proton, minus E, that is the charge on electron, and in between these two charges, the force is the force of attraction. The force of attraction is present in between them, and we can calculate this force with the help of Coulomb's law. What is Coulomb's law? The force, Coulomb force, that is nothing but 1 by 4 pi epsilon naught magnitude of product of magnitude of two charges, that is E square, and divided by distance between them. If that distance is Rn, the square of the distance, that is Rn square, and if number of electrons are Z, then that is Ze square. Now this centripetal force, that is balanced by the Coulomb force, that is nothing but the electrostatic force of attraction between positively charged nucleus and negatively charged electron. Means in between these two charges, the force of attraction, that is equal to this one, and that is balanced by centripetal force, and this is the first postulate of Bohr's atomic model. Okay. This is the mathematical statement for the Bohr's first postulate. Okay. Now we have to study the second postulate. To overcome this difficulty which arises in the Rutherford's model, the Bohr suggests that the electron can revolve for only certain fixed orbit. They are called as stable orbits, for which the angular momentum, that is equal to integral multiple of h by 2 pi. Okay. What is the statement of postulate of Bohr's second postulate of the Bohr's atomic model. Electron can revolve for certain fixed orbit, that is stable orbit, for which angular momentum that is equal to integral multiple of h by 2 pi. This n is also called as principal quantum number, and n that is equal to 1, 2, 3 and so on. For first orbit, n that is equal to 1. For second orbit, n that is equal to 2. For third orbit, n that is equal to 3. Okay. Now, we can rearrange this postulate. We know that the angular momentum that is nothing but r cross p, and value of this p that is nothing but mass into velocity. Mass into velocity, and therefore rearranging this we can write me Vn Rn that is equal to n into h by 2 pi, and this is the mathematical statement for Bohr's second postulate. Okay. Now, third postulate. We have to study the third postulate. Suppose this is the first orbit, for that n that is equal to 1. Then second orbit, n that is equal to 2. Third orbit, n that is equal to 3. And this is the nucleus. Okay. Now, when electron jumps from, as number of orbits goes on increasing, energy of that orbit that also goes on increasing. And when means the energy of first orbit, that is lowest energy. Then the energy of second orbit, that is greater than this orbit. Energy of third orbit, that is also greater than this orbit. And when electron jumps from higher energy to lower energy, means second orbit to first orbit, at that time this orbit, higher energy orbit is called as mth orbit, and lower energy orbit is called as nth orbit. And at that time, when electron jumps from higher energy orbit to lower energy orbit, at that time it radiates energy, and that is nothing but difference in between that two energy, that is equal to energy of a photon. And we know that energy of photon, that is h into mu, that h that is nothing but Planck's constant, and mu that is frequency of radiation. Understood? And this is the third postulate of Bohr's atomic model, and in this manner we can explain the three postulates of Bohr's theory for hydrogen atom. Okay. Now we have to calculate radius of the orbit. Radius of the first Bohr orbit. Suppose this is the radius of the first Bohr orbit, then radius of the second Bohr orbit, radius of the third Bohr orbit. To calculate radius of the orbit, we have to consider these two mathematical statements of Bohr's postulate. Okay. Now, while writing the answer, you must start with these notations ME, VE, VN, RN, Z. Okay. Now, first postulate, that is ME Vn square by Rn, that is equal to Ze square 4 pi epsilon naught Rn square. This is the first postulate. And second postulate, Me Vn Rn, that is equal to Nh by 2 pi. Now we have to obtain derivation for Bohr's radius. Okay. Now rearrange this equation for value of Vn. Value of Vn, that is nothing but Nh 2 pi Me Rn. Now squaring this value. Vn square, that is equal to n square h square 4 pi square Me square Rn square. Equation number 3. Now substitute this equation 3 in equation 1. We can write. Now we know that Me Rn, value of this Vn square, that is n square h square 4 pi square me square Rn square, that is equal to Ze square divided by 4 pi epsilon naught Rn square. Okay. Now, this Rn square that gets cancelled. This 4 that gets cancelled. This pi, this square that gets cancelled, and then this me and 1 me that gets cancelled, and if we transfer this term here, Rn, that is equal to, now this epsilon naught transfer here, epsilon naught n square h square divided by pi, then this me z e square, and this is the derivation for radius of the Bohr orbit. Now for first orbit, this is the first orbit, n that is equal to 1. If we substitute this n that is equal to 1 at that time, Rn that is equal to epsilon naught h square divided by pi me ze square into n square. Now quantities in the bracket, they are the constant, and therefore we can write Rn that is directly proportional to n square. Means we can say that radius of the Bohr orbit that is directly proportional to the square of the principal quantum number. Okay. And if we substitute n that is equal to 1, at that time we get the value n that is equal to 1. Now it becomes R1, n that is equal to 1, R1. This R1 becomes all are the constant, and if we substitute the value of all these constants, we get the value of radius for first orbit that is equal to 0.053 nanometer, that is nothing but 0.53 Armstrong unit. This value is in nanometer and this value is in Armstrong unit. Okay. And this is called, this bracket that is called A0, and that is called a Bohr orbit. This orbit for which the n that is equal to 1, that orbit is called as this. For example, n that is equal to 1, this orbit is called as Bohr orbit, and it is given by the formula A0 that is equal to epsilon naught h square divided by pi me ze square, and this is called Bohr orbit, for which principal quantum number is 1. And if we substitute value of this bracket that is equal to A0, then Rn that is equal to A0 into n square. This is the most important formula, and with the help of this formula we can calculate radius of any orbit. For example, if n that is equal to 1 at that time, A0, value of A0 that is nothing but 0.053. Then radius of second Bohr orbit that is equal to, multiply this value A0 that is 0.053 into 2, that is nothing but the 0.106 nanometer. Only you have to multiply the square of, multiply this value with 2 square with 4. Okay. Then you can calculate 0.053 multiplied by 4, that is 2, 1, 2, okay, 0.212 nanometer. In similar manner, radius of third orbit that is 0.053 into 3 square, that is 9, okay, that is nothing but 0.424 nanometer. Okay, means we can calculate the radius of any orbit, only you have to multiply this value with the square of the principal quantum number. Okay, now we have to obtain the derivation for linear speed Vn for the nth orbit. I hope all of you understood this derivation very well. Now we have to calculate the linear speed of the electron, because that electron performing circular motion, and we have to calculate its linear speed Vn. Now for that purpose, consider this second postulate. This is the second postulate, and consider the radius of the orbit if we consider this equation, that is equation number 2. Now substitute, consider these two equation, equation number 2, and if we give the equation number 4. Now substitute the value of equation 4 in equation 2. We can write then the ME, Vn and value of Rn, that is nothing but epsilon naught n square h square pi Me Ze square, that is equal to nh 2 pi. Now we have to rearrange this equation for Vn, that is equal to, now this pi, that gets cancelled, this n, this n, this n, this n, that gets cancelled, and then this Me, that gets cancelled, and Ze square divided by, now we have to, this Vn, we have to transfer this term here and here twice this epsilon naught n into h, and this is the derivation for linear speed of the orbit in linear speed of the electron in nth Bohr orbit. Okay. Now for Vn, that is equal to Ze square twice epsilon naught h into 1 by n. All the quantities in this bracket, they are constant, and therefore we can say that the linear speed of the electron, that is inversely proportional to the principal quantum number. Okay. Radius, that is directly proportional to the square of the principal quantum number. Means if we have to take the ratio of R3 divided by R4 at that time, that is nothing but the A0 n square, means 3 square divided by A0 into 4 square, and that is nothing but 9 by 16. And we can calculate by using this formula, we can calculate radius of any orbit, but in case of a velocity v1 divided by v2, that is nothing but the linear velocity of first orbit divided by linear velocity of second orbit, that is the n2 divided by n1. Understood? And if we substitute the values of all constant for n that is equal to 1, velocity is, for n that is equal to 1, linear speed is the 2 into 10 raised to 6 meter per second. In some books, its value is given as 2.2 into 10 raised to 6 meter per second. This is the approximate value, and we can calculate the linear speed of the electron in any orbit. Only you have to substitute the number of that orbit, you will get the linear speed. Understood? Radius is directly proportional to the square of the principal quantum number, and linear speed, that is inversely proportional to the principal quantum number. This is the derivation for linear speed of the electron, which is revolving in circular orbit around the nucleus. Okay. I hope all of you understood these two concepts very well. If you like, share. If you like this video, then like, share and subscribe my channel, and also press the bell icon so that you will get notified about my new upcoming videos. Thank you very much.
Oh